Hello students, here this is the last question from this exercise. Give examples of the polynomial p of x, g of x, q of x and r of x which satisfy the division algorithm. Now three conditions were given. Condition 1, degree of p of x must be equal to degree of q of x. Let us check the original algebraic division to understand. Here this is the condition, degree of p of x must be equal to degree of q of x. Now this is the division picture, that means the format. P of x is a dividend, g of x is a divisor, q of x is a quotient and r of x is a remainder. So four parts are there in a division. In a general, if you take 13, if you divide with 3, it will cancel 4 times, that is 12, and when you subtract you will get 1 is a remainder. So here 4 parts are there. This is first one, second, third and fourth. 4 parts are there. Now you can write down 13 is equal to, we have to multiply 3 times 4 plus 1 is a remainder. So 3 4s are 12 plus 1 13. So this division satisfied. So similar to the algebraic division, p of x a dividend, g of x divisor, q of x quotient, r of x remainder. Now in the 4 parts, 1 2 3 4 parts, the degree of the p of x must be equal to the degree of q of x. Like that we have to take an example. Understood? In that way we should take an example. Now I assumed 5x square minus 5. This is my assumption, and I assume the divisor 5. Therefore x square into 5, 5x square, cancel, minus 1 into 5, minus 5, we have to drop down minus 5 and we will get minus 5 and it will be plus and it becomes 0. Now if you see carefully, the degree of this polynomial 5x square minus 5, the degree is 2, the highest power of the dividend, and the degree of the quotient is 2. Therefore degree of p of x is equal to degree of q of x. Satisfied. Now let us check. P of x is equal to g of x. We have to multiply these two, q of x, plus we have to add remainder. So 5x square minus 5 is equal to 5 into x square minus 1. So we are multiplying these two parts, plus 0. So 5 into x square, 5x square, 5 into minus 1, minus 5. So this is the same. 5x square minus 5 is equal to 5x square minus 5. It's satisfied. So we have taken an example and we proved according to that, and this condition was satisfied. Now they are asking us to prove another condition, degree of quotient and degree of remainder. These two degrees must be equal. I am not saying that the terms are not equal, but the degree means the power of that variable must be the same. Here 2 and 2 are satisfied. Now I assumed x cube plus 2x. Just it is an example. Now assumed x square as a divisor. When you divide x cube, x into x square, x cube, it will cancel. That's all. Plus 2x we have to drop down. Now, x square is a higher order than 2x. The power of x is 2. Here the power of x is 1. Therefore, x square cannot cancel in 2x. Therefore, 2x will be remains like that. Therefore, if you see the power of the quotient and the power of the remainder is the same. The power is 1, that is a degree. The power is 1, that is a degree. Now, according to their condition, this is satisfied. Let us check whether according to division algorithm it is correct or not. P of x is equal to Q of x into G of x into Q of x plus R of x. Now, x cube plus 2x is equal to x square into x square into x plus 2x, x cube plus 2x, x cube plus 2x. Now, this is called the division algorithm. This is division. The division algorithm shows the short way of the division. So, this is division. We can convert into the steps. The division can be converted into the steps and we can prove that. Therefore, this is the LHS and RHS are proved equal. So, second condition satisfied. Now, we have to choose that type of examples so that R of x remainder must be 0. The degree of the remainder, not the remainder. So P of x, G of x divisor and Q of x quotient, R of x remainder. So I am going to choose x square plus 1 is divided and x divisor, and x I have to take so that I can cancel x square. X into x square cancel plus 1. Now, what is the degree of the plus 1? Plus 1 is a constant. What is the degree? Now, we can write down plus 1 into x power 0. Plus 1 into x power 0. X power 0 is 1. Anything power 0 is always 1. Therefore, 1 into 1 is 1. Whatever the number it comes, whether it is 1 or 2 or 3, if you keep 5, you can drop down the 5. Therefore, 5 is a constant number. Therefore, the degree of that 5 is always 0. Because 5 into x power 0. You have to write down 5 into x power 0. Therefore, the degree of this term, 5 into x power 0, the degree of the term is 0. Therefore, whatever the number, that means the constant is having degree 0. Now, we satisfied this condition. Degree of Rx means remainder. The remainder degree must be 0. Now I got it. Don't think that the number, the 1 is there. No. We are not talking about the value, but we have to talk about the constant and its power. Now you write down into the division algorithm. P of x is equal to G of x into Q of x plus R of x. Just substitute those values. X square plus 1 is equal to x into x. We have to multiply these two and plus 1. Therefore, x square plus 1. Now here the conditions were given. Now they are asking us to give an example. For the satisfying the first condition, satisfying the second condition, satisfying the third condition. And no example is going to satisfy all the three conditions. They did not ask us. This is question number 1, question number 2, question number 3. That's all. Thank you.